This is a recording on how to use MR-Oncology reading in a 76-year-old woman with breast cancer being treated with capecitabine chemotherapy. The initial page is called spine reading, consisting of T1 and stirs, prior T1s and stir current, and you can see how you can synchronize this reading using synchronization buttons, which don't have to be switched on down here. Once you have looked at the spine reading, you move on to the whole body reading panel. The whole body reading panel consists of T2 images, high B value images, and ADC maps, and we can see the high B value images here, which are B900 images. Just window that and window that. So the bottom panel is prior, the current panel is at the top, and you can go through this whole stack from below upwards, and when you do that you can see that there are some areas here of metastatic disease that have an increase in ADC values with therapy, and you can see here how the signal intensity drops with therapy. Finally, we go on to the OncoTrend software, which is this panel here. The OncoTrend panel brings up the high B value images here as MIP projections. Here is the ADC map, and the histograms will appear here. This is the prior, this is the current data. Let's start with the prior. Double click, create segmentation. The computer automatically creates a segmentation. Use the refine punch tool to remove extraneous signals. This includes the spleen, sometimes the ovaries, the head, and in this particular instance we're going to remove this area of fat necrosis. Double click again, return it back, press histogram. Histogram needs to go in here, so there's your reference image, there's the histogram, and the histogram will appear here shortly. There's the histogram. Take the current study, double click, make it larger, create a histogram. Now you'll notice that the signal intensity has gone down, so there is less included bone marrow. So we're going to have to include a little bit more bone marrow in a second. But again, remove the spleen. We've got a liver metastasis here, which we need to remove. Remove the head. And remember to remove the uterus and ovarian structures. And here we've got a stasis in a vein, which we can also remove. Now, as I said, the volume is decreased compared to the last time, so we're going to increase the volume by adjusting the threshold. So we have approximately the same amount of bone marrow. We could probably put in a little bit more bone marrow, adjust that to 85 as the threshold, and there we are. Okay, so we need to adjust and get rid of the disease in the left breast, and that's about the same amount of bone marrow. Double click, create a histogram. That mask will be applied to the ADC map, and the histogram will appear here, and you'll see that appear shortly. And you can see that this is the prior histogram, this is the current histogram. We can see how this peak here increases with treatment, and this in fact is at about 500. So that represents normal bone marrow. Tumor is usually in this area. This is normal, this is tumor, this is dying disease, and this is dead disease. And you can see the proportions, how the proportions change. If you want to check that, you have to click both histograms, press statistics, and there we see the differences in the histogram values. So here's the volume of disease segmented. You can see that we successfully segmented between 400 and 500 cc's. There's the ADC map, the standard deviation, the skewness, and the kurtosis. And of course these images here are spinnable, and you can see the green areas represents dead disease. In this particular instance, the red areas represent tumor as well as normal bone marrow. But you can move this up and down to be able to eliminate in real time and map where disease is. So you can see that looks very different now because you've changed the thresholds. I hope that you found this useful. Happy to have further questions.